We have decided for this year to go into this consortium because we wanted to prepare the industrialization of the hydrogen storage systems. We have done that with main partners, technical side with some university on tech center, and also industrial side to cover the complete value chain of the hydrogen system.
The main challenges of the THOR project was to design and manufacture thermoplastic tank type 5 or 4.5, starting from nowhere because no thermoplastics material was on the market at the beginning of the project.
Iris was involved in the design and modeling phase for the composite laminate structure. We tried to give the information to the manufacturer about the sequence of angles he needs to produce to have a tank that fulfills with the requirement of the application.
The contribution of NTNU in the THOR project was related to the application of distributed optical fiber sensors as a fire monitoring or detection device. The use of optical fibers, it has a lot of untapped potential for both type 5, type 4 pressure vessels to enable monitoring throughout the lifetime of the structure.
The objective of Institute P Prime was to work on tank safety, tank in fire. We have developed first an experimental device dedicated to assess the mechanical properties of the composite material in fire conditions. And the second objective was to develop simulations to determine the time to burst of a tank subject to fire.
Thermoplastic tanks is a composite that is much easier to recycle compared with a thermoset. With such a composite, you can recover either the matrix or the carbon fiber. You can solve some issues related to type 4 tanks like liner collapse.
The RINA's role in this project was to perform different tests in accordance with the current standard. The main satisfaction for us was to set up and the design of the ETPC, the Extreme Temperature Pressure Cycling Test, because in this test we have to cope with conflicted elements such as high pressure, high flow rate, and extreme temperature.
On SETIM side, we have manufactured thermoplastic tank with a burst pressure at around 1,500 bars, which was close to the objective. And this work leads to a definition of a new machine in which one we will be able to manufacture large-scale tanks with an optimized head.
One of the big interests using thermoplastic composite for hydrogen tanks is the recyclability. During the project, we made different feasibility studies, and we made also different steps to create the shreds coming from the tank and create new panels in thermoplastic composite recycled.
The main challenges in the THOR project was to demonstrate the possibility to wind a thermoplastic composite tank using laser technology to meet not only the normative aspects, such as, for instance, burst and cycling, but also to meet usages for our customers.
We have made a bet for the disposal of the coal with the thermoplastic technology because we wanted to have some recyclability on the hydrogen storage tanks, and also we wanted to use it for the distribution where we have to use under pressure to clean the vessel. And this is the only technology which can do that.